So it says it's connected to a DC voltage source, and assuming they had no charge before they were connected to the voltage source, determine V1 and V2 given these various capacitances. So you would need to know that the charge on a capacitor equals the capacitance times the voltage on the capacitor. And you need to know how to find, the table doesn't work. You need to know how to find equivalent capacitances. So two capacitors in parallel, it's the opposite of resistors. So if I have C1 in parallel with C2, the C equivalent is C1 plus C2, and two capacitors in series C equivalent is 1 over C1, it's product over sum. It's C1, C2 over C1 plus C2. If you had more than two, then C equivalent would be 1 over C1 plus 1 over C2 plus 1 over C3, and so forth. Okay, so we will start by finding C equivalent. So C equivalent is C2 in parallel with C3, and then that is in series with C1. So capacitors in parallel add, so this would be C2 plus C3, and then in series with C1. So C2 plus C3, that's 12 microfarads. In series with C1 is 6 microfarads. So C equivalent is product over sum. So it's 12 microfarads times 6 microfarads times 12 plus 6 microfarads. Which is 72 over 18. Which is 4. Capacitors in series have the same charge, and capacitors in parallel, like anything in parallel, have the same voltage. So right now I can say that I have my voltage source, 12 volts, and that with an equivalent capacitance of 4 microfarads, and I know Q equals CV, and so my charge Q equals 4 microfarads times 12 volts, or my charge is 48 microcoulombs. Now, this equivalent capacitance is the same as capacitor 1 in series with capacitors 2 and 3, which in parallel. And so since capacitors in series have the same charge, I can say Q1 equals 48 microcoulombs. And I can say that Q2 plus Q3 together has to be 48 microcoulombs.
So divided by 2.
No, because they're not identical, are they? No, they're not identical.
Or
Yeah. This was 12 volts. So I can find the voltage across C1. So V1 equals Q1 C1, or V1 equals 48 microcoulombs times C1 is 6, Q equals, I got that, this, Q equals CV. Q1 equals C1 V1. So 48 microcoulombs equals 6 microfarads times V1. Our V1 equals 8 volts. So V1 is 8 volts. Now we also have to find V2 and V3. But that's easy. So the voltage for C2 in parallel with C3, what does it have to be?
The same.
Well, if the voltage across C1 is 8, what's the voltage? Yes, C2 and C3 do have to be the same, but what's the voltage across this equivalent capacitor? Has to be 4, because we have to have a total of 8, and so that means that the voltage on each one has to be 4.